Everybody. So today we're going to learn about the mean absolute deviation, but first we are going to talk a little bit more about statistics. And we're going to use YouTubers again. So I looked up on the internets the top 10 YouTubers based on how much money they earned in 2018. And then I also looked up the number of subscribers. So this is bivariate data. Bi meaning two, like a bicycle has two wheels, and variate meaning variables. So each one of the elements in our population, all of these elements have two variables associated with them. How many subscribers they have and how much money they earned. And both of these are in millions. Crazy. Do not drop out of school to become a YouTuber. These guys are making a lot of money, but most people don't make anything at all. All right, so our bivariate data, we have two variables for each element in our population. And let's go ahead and make a scatter plot and see if there's any association between the number of subscribers and the amount of money they earned. All right, take a look at this scatter plot. Can you figure out the form? The strength, and the direction. This one's hard. You know what I expected was that our line would go like this. The more subscribers, the more money, it makes sense. This is why we do scatter plots, is because it doesn't always look the way you expect it to look. If anything, this almost has a negative slope to it a little bit, because I got a high point up here, but you know what? I got a lot of low points up here too. So for a small amount of subscribers, I have some people who are making a measly $11 million. Why does that keep erasing? A measly $11 million. And then I got some people with the same number of subscribers who are earning 26 million, the most of anybody. And then these people who have more subscribers have, they're kind of in the middle. They're not high or low. So what I would say for this graph is no association. And isn't that surprising? Why are they telling me to like and subscribe then? I have a feeling it's because we are up here with the highest earners. So if I wanted to continue my study, I would expand my sample. Okay, so that was fascinating. The next thing we want to do is we're just going to look at one of our variables, okay? So to find the mean, the median, and the mode, and the range, we didn't look at bivariate data. We looked at just one variable at a time, so that's what we're going to do right now. Let's just look at money. So we're just going to look at money. We've got 11.5 million. We have 12 million, we have 13, and then another 13, and then 14, and then 17, and then 17.5, 18, 20, and 26. And these are already in order from smallest to largest, which is nice. So we should be able to find the mean, the median, the mode, and the range. Hopefully you've gotten really good at this. So to find the mean, I'm going to have to add all these numbers together. So 11.5 plus 12 plus 13 plus 13 plus 14 plus 17 plus 17.5 plus 18 plus, oh, this is why I was kind of calculator. So I'm going to start over. Plus 20, plus 26. I like a two-line calculator so I can see that I'm typing everything incorrectly And if I make a mistake, I can just delete it. All right. Now, if I hit divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, I will get the wrong answer. Your calculator will not do order of operations for you. Your calculator would only divide the 26 by 10 because order of operations says we divide before we add. So please make sure you're not just typing everything into the calculator and asking it to do the math for you. So our sum is 162. So when we added all of these up, we got 162. And then we're going to divide that by 10, which we could just shift the decimal, but we'll do it anyway. So when we divide by 10, we get 16.2. So the mean is 16.2. The median, to find the median, I am going to get rid of the low and the high. The low and the high, the low and the high, the low and the high, until I have 1 or 2 numbers left. So 14 and 7 are the 2 numbers in the middle. I need the number in the middle of 14 and 7. So I'm just going to average those two together. So 17, not 7. 14 plus 17 equals 31. Divide that by 2. And we get 15.5. So 15.5 is the number in the middle. That is our median. The mode is just the number that shows up the most often. And we have 2 13s, but we don't have 2 of anything else. So the mode is 13, and the range, we're just going to subtract the biggest number minus the smallest number. And we get 14.5. All right. Let us find the mean absolute deviation. All right, so mean, we know means average, so we're going to need the mean. Absolute. So for absolute, you should be thinking absolute value, right? Our absolute value bars, which means we're going to make everything, the deviation positive. We just want to know how far away it is. We don't want to know positive or negative here. And deviation. So mean absolute deviation means how far away is it? How far does it deviate from the mean? So in order to figure out the mean absolute deviation, I'm going to need to know the deviation of every single one of these numbers from the mean. So what I want to know is how far are these numbers from the mean? So I'm going to go ahead and make a table because I need this information for every single one of these numbers. Okay? So we'll start with 11.5. 11.5 is smaller than our mean, but I don't care because we're doing absolute. So I'm going to do 16.2 minus 11.5, and that gives me 4.7. So the deviation of 11.5 from the mean is 4.7. All right, and then we do the next one. 12. How far away is it from the mean? Well, I can take the 12, subtract it from my mean of 16.2. I got a negative number. So I could switch the order and do 16.2 minus 12. But remember, we're going to take the absolute value of all of our deviations. They're absolute deviations. So it really doesn't matter if they're negative or positive. I just want the 4.2. All right, next one, 13. So 16.5, no, 0.2 minus 13 gives me 3.2. And both of the 13s are going to have the same deviation. So this point, this data point of 13 is 3.2 units away from the mean. That's what we mean by deviation. So deviation. How far away is it from the mean? All right, 16.2 minus 4 is going to be 2.2. 17 minus 16.2 is going to be 0.8. 17.5 minus 16.2 is a syntax error. 17.5 minus 16.2 is 1.3. 18, darn it, 18 minus 16.2 is 1.8. 20 minus 16.2 is 3.8. And 26 minus 16.2 is 9.8. Okay, so these are all of our deviations. So these numbers in the middle, they're pretty close to the mean. 0.8 away, or 1.3, or 1.8, or 2.2 away. But these numbers on the edges, they're much further away. So what we now have are absolute deviations. What we're going to do with those absolute deviations is we're going to take the mean. So we are going to add up our deviations and divide by 10, the number of deviations. So we're going to find the average or the mean of the deviations. To find the mean absolute deviation, I'm going to take the mean of the deviations. So we're going to do what we did when we found the mean of the money. We're going to add them all up and then divide by the number of numbers, which in this case is 10. So 4.7 plus 4.2 plus 3.2 plus 3.2 plus 2.2 plus 0.8 plus 1.3 plus 1.8 plus 3.8 plus 9.8 equals 35. And then we divide that by 10, we get 3.5. So our MAD, our mean absolute deviation, is 3.5. And that's a pretty small number because all of these numbers are pretty close together, which means they don't deviate from the mean very far. All of these numbers are pretty close, within 10 of our mean of 16.2. Okay, now it is your turn to do what I just did with the subscribers. So we did it with the money. Now I would like you to find the mean, the median, the mode, the range, and the MAD, the mean absolute deviation for the number of subscribers. So please pause the video right now, and when you have finished finding all the things I asked you to find, then hit play and let's see if we got the same numbers. Okay, so for the median, I got 25.1 because both of the numbers in the middle are 25.1. For the mode, I got 25.1 because it's the only number that's duplicated. If all of the numbers were different, there would be no mode. So there's only a mode if you have a repeat. If we had two numbers, two sets, like 25.1 and 25.1, and then we also had 104 and 104, there'd be two modes. The range, just subtracting biggest minus smallest, is 102.1. 0.1. Okay. And then the mean, I added all of these numbers up and got 397.4. I divided that by 10 and I got 39.74. So that's my average. Now, notice how the average is pretty far away from the median. And it's because we have a lot of points that aren't that far apart, and then we have these 2 points that are way bigger than everybody else. And those big points tug at the median and pull it up. Or tug at the mean, I'm sorry. They tug at the mean and they pull it up to where 39.74 is bigger than most of my numbers. It's larger than all but 3 of my numbers because these huge numbers pull the mean up. While the median is always the number in the middle no matter what. It's just in the middle. So if you have really big or really small numbers down here, they will sway the mean, but they don't affect the median. Okay, now to find the mean absolute deviation, I found the deviation, or the absolute deviation, since there's no negatives here, right? I took the mean and I subtracted this number, and that's where this number comes from. I took the mean, I subtracted 13.1, and that's where this number comes from. So took the mean, Subtract 18.2, that's where this number comes from. Once I get up to here, when I take the mean and I subtract this number, I would get a negative number. But because it's the absolute deviation, I write it as positive. I'm not interested in knowing if it was bigger or smaller than the mean. I just want to know how far away, the distance from the mean. See, another use of absolute value, and you thought it was useless. And these as well would have been negative, but we made them positive by taking the absolute value. And then I added all of these deviations together and I got 300.6. And then I divided 306 by 10, the number of numbers. So I get a MAD, mean absolute deviation, of 30.6. 30.6. Now that's way bigger. Our MAD for the previous was like 3 point something. This is way bigger, and that's telling us that our numbers are spread further apart. So the bigger the mean absolute deviation, the more I know that my numbers were spread really far apart. All right. I hope you did well. Thank you for watching all the way to the end. You are amazing.